So today we're going to do properties of rational exponents, and these are very similar to other properties, but just a few things to note is that some things that you've already worked with. So you've already done the square root. Here, let's change the color here. I want black. You've already worked with something like the square root of, I don't know, 9, and it's 3, right? Something to note though is that there is an invisible 2 here with the roots. Invisible 2. So that this is actually 9 to the 1/2 power. So any root is actually a fractional power, and that's something that maybe should have been taught when you were first learning it, is that any root is a fractional power. So notice that any root is the denominator of a power. Denominator. Okay. So if I have, even a 10th root of any number, like, I don't know, 1200, it doesn't matter. This is 1200 to the 1/10. So notice that anything with a fractional power is a root, and anything with a root is a fractional power. They are the same thing. It's just a lot easier sometimes to comprehend it as a root, but sometimes it's nice to know that. Another thing to note is that if I have something larger, like a 4th root of 32. Let me see, 2 times 2 is 4. 16, sorry, 16. Remember, this is 4 numbers that make 4 identical numbers. Okay, so that would be like taking 3 times 3 times 3 times 3, which is not 16. So that's not the right answer. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that this here would just equal 2, would equal one of them. And then also, what we can do is, and I'll talk about it in a minute, but things like this, 3 root 6 squared, we actually can't put that in the calculator very easily. We're going to have to change this so that this is the numerator, or the top of the fraction, so 2, and this is the denominator, or the bottom of the fraction. And then this we can put in the calculator like so. Okay, so that's what we're going to do today. So I just want to take time to look at that. I'm going to grab my calculator because we're going to need the calculator today. Okay, so we're all ready. So number 1 says compute without a calculator, which we can do because we have the 3rd root and a square. So just remember, we always root first when we do this. It actually technically doesn't matter, but rooting it first helps. So we have a 3rd root, and if you don't know, so we're just going to look at this green highlighted part right now. And that 2 is going to come down later. So the 3rd root, if you don't know what that is, then we guess. So is it 1 times 1 times 1? No. 2 times 2 times 2? No. 3 times 3 times 3? No. 4 times 4 times 4? 5 times 5 times 5 is 125. So yes, it is 5. So this green part, and I'll write it in green, changes to a -5 because it is negative. And then that squared, I'm going to highlight it in yellow here, that squared is going to come down. -5 squared is 25. So we don't need a calculator here. 4th root of 81, again, if you don't know, 1 times 1 times 1 is 1, so no. 2 times 2 times 2 times 2 is 16, so no. 3 times 3 is 9, times 3 is 27, times 3 is 81, so yes. So this is just going to equal 3. So 81 to the 2/4 power. This one, again, we can actually reduce this fraction, so if we can, let's reduce it. So it's 1/2. And remember that a half power is a square root. So this is just the square root of 81, which is 9. Fair enough. So now we have 3/2. Now remember, half is our root. So remember, when we set this up, that's how we do it. This 2 is going to come in front as a root. And so the 2nd root, or the square root of 36, is 6. Then 6 cubed, I'm going to use my calculator, so 6 times 6 times 6, I believe is 216, and I'm right. So notice we can solve these. Again, it says without a calculator, I kind of fudged a little bit there, but again, 6 times 6 times 6 is 216. So this one we're going to use a calculator. There's no way to put this in the calculator, so what we're going to do is we're going to put this as a fraction. Just remember that this becomes a denominator, so that's a denominator. Okay, whatever's here is the numerator, but since there's none, it's just a 1. And I'm going to put this in the calculator like this. So I'm going to do 201 power button parenthesis 1 divide 5 parenthesis, and I'm going to make sure my decimals are turned on, so I get 2.89. Here, this one's pretty straightforward. We can just put in the calculator. Don't forget the power button and the parentheses. So 276 power button parenthesis 4 divide 7, and I'm going to get 24.82. And there we go. So we want to prove that the left side is equivalent to the right side. Whenever we have two powers in a row, so see how there's two powers here, so I'm going to highlight that in green right here. Two powers in a row will multiply only if there is no pluses or minuses, or adding subtraction, inside the parentheses. And this is something that you guys and girls already know. So if I have something like this, x plus 6 squared to the third, there's two powers in a row, but the plus means we cannot do that. However, if we had 6x squared to the power 3, we can actually multiply those. Okay, so we can do that here. So here, the highlighted part, we're going to multiply. So we get 2.08 to the 10 over 20t. Now what is 10 over 20? That's 1/2. So 2.08 to the 1/2 times t. Now what is the 1/2 power? And there's a little, I need to put a t there. There's a little typo there. So what is the 1/2 power? That is a root. So we got root 208 to the power of t. And now we've matched it. So we're done. So we just want to match here. And this is actually the specific standard. The standard states can use these properties to prove something that is equal, and that is the standard. So this hits the standard. 27, again, 2/3 is a root. So we have a third of 27 with a squared t. The third root of 27 is 3 times 3 times 3 is 27. So this stuff here that I'm highlighting, all that is going to turn into a 3, and then the 2t comes down. Well, what is 3 squared? Right? 3 squared is equal to 9, and the t is going to come over, and we've matched. Okay? So notice these really funky rules where we can like manipulate things. That is the standard. Oh, and then here's also a thing that hits the standard. It says, write 5 different ways that are equivalent to 8 over 1/4. Well, that's not that hard, because isn't 8 over 2/8 the same thing? Right? What about 8 over 4/16? What about 8, and then we have 1/2 to the 1/2? Isn't a half times a half a fourth? That's the same thing. What about 8 to the, what is it? 1/4 to the 1. That's the same thing, right? What is the 4th root of 8? So this would be the 4th root of 8, right? Because it's a fraction, so there's another one. What is the 4th root of 8? Well, let's see here. 2 times 2 is 4 times 2 is 8. So it's a decimal. There's no way you could do it. But there are 5 ways right there. We could just get going bigger, 8 over 32. Okay, so we can get really creative. Like we could do x over 2 and then we could do 1 over 2x, because when you multiply these, the x's are going to cancel and we're left with 1/4. So there's a lot of ways you can rewrite these. There's an infinite amount of ways. There's no set 5 right answers. There's millions that you could write. So finally, we're going to solve. Solving isn't too hard, so we're just going to get that power by itself. So we're going to add 6. So we have 2x to the third is equal to 16. Divide off the 2, so we get x cubed is equal to 8. And then again, to get rid of this power, we're going to third root. So notice powers and roots are opposites, so we're going to get 2. Because 2 times 2 times 2 is 8. We could double check our math, plug it in if we'd like. Number 10, same thing, we're going to get the power alone, so I'm going to plus 1 to both sides. X minus 6 to the fourth is equal to 625. And then again, since the power's all alone now over here, we can root it to the fourth so that the power and the root cancel. So notice roots and powers are opposites here. So those are going to cancel. X minus 6 and 625, I'm going to write it like this, to the power of 1/4, and put it in my calculator. Sorry, this is 25. So 625 to the power of 1 divided 4, and we get 5. It's going to be plus or minus. That's because odd numbers, so odd roots is normal, and then even roots, here this is even, so even is plus or minus. Okay, so we're going to add 6, It's a little tricky though because 5 and 6 make 11, but we have negative 5 plus 6, so we also have a 1, so this has 2 answers. Kind of interesting, doesn't it? And those are all the power rules that we're going to work with. The idea is that roots and powers are opposite, so they can cancel. The idea that we can manipulate all these. Now this is a very common ISAT, SAT type of question where they have, it's multiple choice. They'd have this, and they'd have you pick A, B, C, or D. That's one of these. Same thing here. This would be like the question, and then this would be choice D or something, and so you have to prove that those are the same so you can pick the right choice. Very similar to what's on the standardized tests. And then these are the basics. How to put in the calculator here, right here. How to put a root in the calculator, because you have to change it to a power. Remember, roots and powers are interchangeable, but a root and a power are opposites when they're whole numbers there, when we're looking at that. Then we can break it down and do it by hand. Okay. If you have any questions, let me know. Not too complicated, but there is a lot to it, so if you don't practice, it'll be hard.